Stan Gibilisco here. I'm going to describe for you the anatomy and operation of a simple device called an electromagnetic relay, which you will find described also in Chapter 8 of my book, Teach Yourself Electricity and Electronics. 6th edition, published in June of 2016. Actually, it's not just mine. It was co-authored by Simon Monk, who provided new chapters on the Arduino device and on microcontrollers in general. But what I'm going to show you now is a simple electromagnetic relay device. A relay is a remotely controlled switch controlled by a direct current which you apply, or a direct current voltage which you apply to an electromagnet intermittently to make it either into a magnet or not. The terminals, let's say this is a single pole double throw switch. Pole X can be switched to either pole Y or Z depending on whether or not current flows in this coil, direct current, creating an electromagnet. Now suppose that it creates an electromagnet such that the north pole is at the top and the south pole is at the bottom. This permanent magnet right here is such that the south pole the north pole is at the top and the south pole is at the bottom. This springy strip is such that it maintains contact between points X and Y by holding up this lower disc here with this upper disc here so that they make contact. There's no current flowing in this coil, so there's no magnetic field here, but this is a magnet, north pole at the top, south pole at the bottom, and this springy strip is such that it holds by mechanical tension these two contacts right here together until we apply that direct current to this coil, creating a strong north magnetic pole here which attracts the south magnetic pole of the permanent magnet here. Down goes this disc and down goes this disc to make contact between point X and point Z. So when there's no current flowing in this coil, current can flow from X to Y, but not X to Z. When we apply a current to this coil of the proper polarity, or a control voltage of the proper polarity that provides the current going in the right direction, literally speaking, to get a north pole here, then it yanks this permanent magnet down with force enough so that this springy strip gives way and allows contact between X and Z, and current can flow between X and Z. And it doesn't just have to be current. It can be radio frequency energy. It can be alternating current, direct current, audio frequency. It can be just about anything. And the advantage of a mechanical relay, of course, is that it operates much faster than any mechanical switch you'd operate by hand, but not nearly as fast as a purely solid state switch could do. But it's immune to some of the detrimental vulnerabilities of solid state switches, most notably the ease with which solid state equipment can be damaged or destroyed by an electromagnetic pulse. It's a lot harder to destroy a relay that way because it's old-fashioned. It was built before the days of convenience, convenience over durability and I guess, dare I say, in some cases, even quality. But that's the old fuddy-duddy Stan Gibilisco speaking. Once again, you'll find this in Chapter 8 of my book, Teach Yourself Electricity and Electronics, 6th edition, mine, co-authored with Simon Monk. Figure 8-6A, an electromechanical relay. Stan Jabalisco signing off. Until next time, so long.